So anybody use awk HTTP in production? HTTP, okay, so good, yeah, couple. HTTP for us, yeah, okay, cool. All right, so, but a good spread on both sides. So this is a heavily awk HTTP geared talk because we use awk HTTP at work. So yeah, it's the HTTP for us stuff. We have pretty extensive test coverage, so I'm pretty confident that it will work, but I don't have direct experience with it because I don't use it in production. So, but I am interested in getting more people who have experience with HTTP for us evaluating the code that we're generating and seeing if they can contribute back in some way. So talk to me afterwards. So this is a standard routing layer of awk HTTP. We have this very interesting DSL for composing routes in awk HTTP. These directives are very convenient to just kind of slam out a server, but very difficult to reflect out specification languages from. So there are a number of projects that have in the past attempted to actually annotate the awk HTTP infrastructure, or annotate the case classes that you use to back these things. And then use that to reflect out some sort of Swagger specification from existing code. This is wrong. This is wrong for a number of reasons, mostly that it doesn't really work, and it won't save you if you make a mistake. You find out when your customers complain to you that your specification is wrong, right? This is backwards. You need to start with your documentation first. So the fact that we have code that's undocumented is not helpful. So we can start with this as a baseline of what we want to generate from this project. But again, it doesn't have, if you start annotating everything, then first of all, you don't know if you've missed an annotation. And then additionally, the annotations end up cluttering the actual code. So now you're dealing with this tremendous amount of boilerplate on top of your boilerplate. So you've got like both levels of problems. You're trying to just document something. So instead, so I like, first of all, implementing functions, because I like having a specification that I'm implementing. I like having strict types for the thing that I'm actually writing. And I want my compiler to help me as much as possible. HTTP is a giant function from string to string, or string to async string. So if you're talking about actually trying to derive types out of HTTP, that's also a losing strategy. So starting with the actual starting with the specification and constraining your view of what you can even do in HTTP is critical. So this has ended up working tremendously for us. On my team in particular, we actually found some pretty significant security vulnerabilities. So I was talking about security earlier. I love that we found vulnerabilities from the compiler. Just migrating code into this system exposed bugs. So being able to say, no, actually, it's impossible to do this. There is insufficient information at this point, and we thought that there was sufficient information, but it only came out of trying to migrate into these more strict types. So that will find me after. I'll show you the actual diff. It's awesome. So if I implement this handler trait. The handler trait comes with a bunch of abstract methods. So if we look at what those methods look like, so in this case it would be creating a user. So we have one parameter, which is the user. This over the specification would be JSON. The first argument, though, you'll see is this thing called respond. Respond is a singleton type of the individual response type of an individual function. So I cannot respond with a different type from a different function to this function. You see that the future at the end is a user resource create user response type. So that's it. It went from that singleton type and then produced the resulting types. So there's no way at the compiler level to respond with the different types. They're just completely different. So we can actually look at what this looks like in terms of generated code. We have the response type itself that closes over the status code. This is describing which status code is for each one of the branches of the create user response class or abstract class. And then we have OK and forbidden as two valid responses. Notice that neither of those take parameters because OK and forbidden both specified that they did not have any message body. So OK could have been no content in this case. Forbidden also has no body, so you're just responding with like a 401 or something. If we implement a simple version of this function, the easiest thing is to just take the user object and return immediately with a future successful of respond.ok. That satisfies the required type. We additionally, if we start adding, actually I think there's a slide for that, so let's go to the next one. If we swap out the static implementation that we had before with something that writes to a database, returns the future of long, we've now used that value, we flat mapped that thing, and now we're going to yield a respond.ok. So the idea is that no matter what your business logic is, you're still constraining your edges to these well-known types. So good separation of concerns there. Then we can extend it a little bit further. If we try to get from a database, this is going to return a future of the option of user, and then we can just fold like you would normally do. But you can see here that our not found has now added a method or a parameter to not found that returns an error code. So it's not only going to return 404, but it's also going to return the text of the text plain response of no user found. Otherwise, if we did find the user, then we respond with OK of the user. So we can see that we've actually changed our specification to have these new parameters as well. Something interesting that I will point out here is that even though we're using OK and not found as symbols, there's nothing tying me directly to HTTP here. You're not actually seeing anything on the HTTP layer. So the implementation of this trait, this implementation of the handler, is completely abstracted from the underlying transport mechanism. So if you wanted to write some sort of tests that tested just the function in isolation, you have this implicit separation of concerns by construction. Like the handler itself, you can test the handler. You can supply a mock handler to test the routing layer if you need to. The whole platform is, what you're writing is separate from the routing layer to the handler. Those are completely separate concerns. So you can see that actually ends up creating, first of all, readability. I no longer have to worry about the particulars of the routing DSL of the framework that I'm using right now. Or if I'm switching from one framework to another framework, most of the types that I'm dealing with are already mapped for me. So I don't actually have to worry about, I'm going to migrate from awk HTTP to HTTP4S or HTTP4S to awk HTTP if I'm using if you have some specific use case that needs a particular framework, right? So you can very straightforwardly swap from one to another because most of your types are actually abstracted from you in that respect. So we can actually see here, this is a complete definition of a server. This is the create user, and get friends functions are all stubbed out. All you do in awk HTTP is you call user resource. So there are two concepts. There's resource and handler. The resource object has most of the support definitions and a function called routes. You pass your user handler into the routes function. And then you get a specific type response, like a type of the framework that you're working with. So in this case, we're getting a route because we're working with awk HTTP. So awk HTTP has this route concept. So we get a route. We can compose those routes with other things in awk HTTP. So migration is also very easy to migrate into this system because the idea is it's sort of at every level you have at the edge. There are no more dependencies between Guardrail and the underlying frameworks. There's just, you get the underlying framework back and you can do whatever you want at that point. So you can use whatever testing frameworks already exist for the libraries you're using. You can compose them with other things. You can compose different servers together. It's at that point, it's entirely up to you. So you take that server that we discussed, or that we created earlier, rather, that route there, and then let's say you have some routes that you're migrating, let's say normal routes. So if you combine normal routes, your existing routes, with your new routing infrastructure, you combine that to port 8080, and now you have a completely running server with partially statically well-typed code generated from Guardrail and partially handwritten code that you're not yet migrated. So this is a useful and good working pattern. So you can actually do this sort of migration in a very straightforward and well-supported way. So, yep. Well, so we can see that if we change the schema, if we add this body, I think that, yeah. So if we add a response body to this 200, then we can actually see that now instead of it used to not require a string, now it does require a string, and we can actually see that the response will require us to supply this OK here. So we actually, if we attempted to compile this, I wonder if this will compile. Yeah. So we'll see that in the code sample shortly. So the string that is supplied on that OK is now required. So if we had compiled this without changing that OK to accept that string, then this would not have compiled. So from changing a Swagger specification, you're getting compiler errors in your application. This is super good. This is what we want. So if I then pop over to, yeah, so let's jump to the actual live coding part of this, which is going to be interesting. And also, I work best when continually interrupted. So if you have any sort of questions or you want to shout things out at me while I'm typing, that's totally welcome. I encourage it. So I have this routing DSL taken from the UCK-HTTP documentation. This is what their standard routing DSL looks like. But we're actually going to start by creating this to-do resource with an empty to-do handler. So we can actually see here that if we compile, this will actually say, whoops, not even found, because import, let's see. Right. So if we attempt to compile it now, it'll say, hey, object creation impossible since method create item in this trait is not defined. So what we can do is we can grab the error message. And I like when there are more than one method not defined errors, because then it will print the entire stub for the class for you, which is great. So we can actually see here, this is a reasonable, at least to start, definition of this thing. And I've forgotten the that no parameters for this function, and it returns a Scala concurrent future, which it does. So we can compile this. It will compile. It doesn't do anything yet, but at least it does run. So if we attempted to run this, we can actually first of all attempt to call that create item function, and it will explode. Because I did not. So let's take a look at the specification to find the route. So to do. So if I do that, then we get an internal server error, which we expected because we had that implementation is missing. So excellent. Let's provide an implementation for this function that just ignores any parameters that we would have gotten and returns a future of just an OK. So let's we do that, we don't need this anymore. And we can say future successful respond.ok. So if we write this now, let's start back up, we can actually get, we'll see that the responses that we get are very empty HTTP responses. So let's log this, the verbose chatter talking to this server. Did I? 201, of course. So we've got we'll see that the when I make a request, I'll make a post, and that'll respond with a 201 immediately. And that's also true because I specified that this returns a object. So let's just stub that out. So if we now run this, this will, every time that the plugin detects that you're trying to compile, anytime the compile action is run in SBT, we also have a Maven plugin. But anytime that you run compile, it regenerates all the code, which means that if your business logic is completely abstract from the routing layer, if your routing layer has bugs, or if there are any bugs in Guardrail itself, or missing features, or something in the future, one of the big problems that I have with most code generation frameworks, especially in Swaggerland, is that you have to commit your generated code. And this is a tremendous sin in my respect, or in my opinion, because this ends up preventing you from continuing to iterate on the back end, because now everyone who has ever generated something from your tool, now they have this locked in time version of this thing, which may have bugs or may otherwise have missing features or things like that. So being able to generate this every time is absolutely critical. So we can see I'm going to post verbosely, and we can see I got a 201 created. So that's what we expected. So if we now put back this definitions item, we can actually see, first of all, the definition of an item is it's just an object defined in OpenAPI Swagger specification. And it has two required fields, ID and contents. The ID is an integer, and the contents is a string. So if we change this created to, we're going to import from to-do definitions as well. And we're going to say, yeah, we want that one, item. And then the first thing is a long, and this is an item, right? So we've got that. And let's, if I'd thought ahead, I would have made it so that you can hit enter or something and cancel this bind. But I did not think that far ahead. So if we make this request now, we should be able to see a JSON object come back with just the item that we created. We can see the ID is 1, and the contents is this is an item. It is normal JSON, which is great.
How does the serialization happen?
So on the back end, we use Circe, and we use Circe for Akka HTTP and also HTTP for S. It does the derivation of all of the encoders and decoders for you, and does some special mapping around read-only fields that you can specify in Swagger as well. So that's it's all on the back end. It's code that you would be able to write yourself. It doesn't use reflection, doesn't use as instance of. It's all like reasonable code on the back end. And we've had a couple of situations where during the development of Guardrail, it's made sense to just take the generated code directly, move it into source main Scala, modify it to fix bugs like critical issues where it's like this feature doesn't even exist. So they migrated code into their code base, patched it, sent an issue to me, I patched it in Guardrail, and then they were able to delete the code once it was fixed, like once the missing feature was added. So yeah, it's a good iterative strategy. Additionally, I want to talk about, if I have a couple of minutes at the end, I want to talk about the iterative nature of Scala Meta. So Scala Meta is what's being used on the back end here, and we're also expanding into Java parser. Let me actually do one more change here. I'm going to add a property to this field and see that my code that previously compiled and ran will no longer compile and run. So user is actually going to be, instead of a item, let's say user, type is an object. And I'm going to say required ID name, and properties are ID type integer, and name is type string, right? So if I do this, and I say the user is actually a ref to definitions user, then this should no longer compile. So we can actually see, I'm not going to fix this compiler error because this is, the whole point is that if the specification language changes, if you're whoever's designing your APIs, or if anyone who is part of your build process, oh, because I didn't mark it required. Good. Okay, cool. So, user. So now the user field should be required. You can see not enough arguments for apply. You can see ID long contents, and then user is a user object. So this actually did what I expected it to do. This means that now even people who are not interested in writing code, not interested in writing Scala, not interested in collaborating with you directly in your project can write your API specification. They can start writing their implementation against their spec. Then you generate your service based on that specification and implement the business logic. So this fundamentally changes how teams work together at a large scale. So I highly recommend that you use this thing because it's cool. So if we have a couple of minutes. If we want to add custom support for a type that is not supported in Swagger, if we want to add like business logic that is specific to Scala to help you write better Scala, then you can define your custom types, or if you're using the refined library or anything like that, you can already specify a refined type, and so long as you have a refined adapter to Circe, it should automatically pick that stuff up. We're going to write something custom to do this right now, where we can say new non, if actually we can say, so we have a string, and then if the string is non-empty, then we can say, I can't remember exactly what the syntax of this thing is, so map, flat map. Yeah, so if we say decoder, yeah, cool. So if it's non-empty, we can say decoder const of new non-empty string, else we can say decoder failed, and then yeah. Oh, okay. That would be good. I'm going to continue with this, but that would have been helpful. I don't typically do this low-level stuff anymore. Yeah, non-empty list string required. So I'm very interested in making it so that you can use the standard decoder, encoder strategies that you would use to say like a cat's non-empty list or anything. Like we use cats under the hood, we use Circe under the hood. So long as you have something that's capable of encoding or decoding from that thing. So this is, I'm going to actually do the emap thing because decoder string emap Cool. So we can actually do that much easier then. Emap. So if that, then we can say right of that value. Otherwise, we can say left of that. And as a result of that, this should at least compile. Okay. Implicit encoder. So it is actually looking for an encoder now. So right. So contra map on non-empty string. So that should give us something that works. And then again, we don't have all of the definitions, but if we make this optional again, then we can see the generated code. Yeah, so it asks for, now we need it to be a non-empty string. And you saw the definition for that non-empty string. It's just a map on top of, or it's some sort of handler on top of string. So adding additional business logic into your types, and then that's all folded back into the routing layer of the underlying framework that you're working with. So that's good. Additionally, I want to extol the virtues of multi-level testing techniques. I hate writing tests, and I hate tests just in general. I want my compiler to do everything for me. But unfortunately, if I make a mistake, then that impacts all of you. So we have 5 levels of tests. So we have, first of all, the compiler. We write good code, but then if the compiler starts complaining, then obviously that's not good. So we've got the compiler as our first level. Second level is we actually have tests that run against the compiled code. So we have tests that test, like it runs the generator with some stock strings, like static strings, and then it verifies the structure of the generated code. Then we have the third level of tests, which is running the code generator. So we actually have, as part of our CI build process, we actually run against a number of known tricky Swagger specifications. And then we, on the fourth level, try to compile what we generated. And then we actually have tests that are written against generated code. So we actually test way too many times. But this ends up finding some really cool regressions and other things, and enables to call back to a previous presentation from, I think, yesterday, the Kaz Serra's talk on having a successful open source project. We have a platform in the way that the tests are designed to enable people to contribute without fear. Because people can come in and start just throwing code around, and it just won't be able to be merged because the code will not pass the tests. So it's like, this is the best thing. And then if somebody comes in and says, well, I have this really weird edge case, they send me a Swagger file, I drop it in the thing, and then I look at what the output of it is, and I literally copy and paste the generated code into the tests. So if we can take a look at Backtick Test. So backticks, there used to be a bug in Scala Meta where Scala Meta would not correctly encode special parameters in Scala. So you would have to, like if you have a variable or a value with spaces in it, or a type with spaces in it in Scala, you can surround it with backtick. But Scala Meta had a bug that did not have this capability. So I have this very unpleasantly structured Swagger file with loads of like dashes in routes, dashes in packages, like spaces in various places. And what I want is I want to make sure that the generated code exactly matches this AST from Scala Meta. I want to be able to say the client here has to exactly match this structure, even if this is even if this is undesirable. If we look at this class name, like -e dash package capital C client, like it doesn't. We don't even know how to correctly transform this into like a human usable or expected class name. Like there's this like dashes, underscores. Like we usually handle snake case, converting that into traditional like Java style package, like all camel case. But in this case, we just didn't know how to handle this dash. But even so, the test verifies that that hasn't changed. We want to make sure that we're exposing a consistent interface to the user. So That because we have this structure and because we can walk this AST and say, these are the set of things that should be in this thing, this is the set of things that should not be in this string, then we can actually talk about comparing the structure of the entire class. Like the generated class structure should be exactly equal to the structure that we have in our test. So Scala Meta is an amazing project. If you don't use Scala Meta and you're doing CodeGen by hand, please consider Scala Meta. It's fantastic. Like the structure of it is just such a joy to work with. So that's pretty much all I have to talk about right now. But I think I have a couple of minutes for questions. Okay. So any questions?
On the HTTP4S CodeGen, is that something that would still bind to futures, or are you using cat's effect there?
We're actually allow any F to be passed in.
Awesome.
Yeah.
With the sync instance, I presume?
I would expect so.
Okay.
Again, don't use it, so I can't say anything about that.
Sure.
Yeah.
Can you show some Scala Meta code?
Yeah, of course. So as you're supposed to, when you're going into a demo, you have dirty code all over your system. So ignore the fact that there are probably going to be squiggles everywhere. But while I pull this up, I saw another question. Yeah.
You didn't show an example of just like sum types, like you can do like, one of in Swagger, and so is that a supported scenario?
Yes, so we have, as of, I think 3 weeks ago, we have support for all of.
Okay.
We're adding support for the more specialized forms of validator using, we're looking at using Refined for that. It's not currently supported, but I'm interested in discussing with people on whether or not they would, first of all, use that feature, since it's been mainly demand-driven development, but then also how they expect that feature to work. Because that's, I have not needed it, so I don't know how I even would want to write that. So yeah, if that's something you're interested in, talk to me.
Yeah, so not today.
Definitely not today, no. We do have enumerations and we have all of. So we have, especially with the ability to reference other YAML files from YAML, you can already do like code reuse and like splitting definitions apart into different services. Like there's a lot of structure that you can get out of the way that YAML works and that Swagger or OpenAPI works today that kind of gets around this. It's something that I definitely know is it's a glaring hole in our implementation. But we started from a ground up, like ground up, because when I tried to run the official Swagger CodeGen, there was a bug that has since been fixed. But they forgot it's all mustache templates internally for them. And they forgot a new line on one of the files. So all of my classes were on one line, which is like, okay. So we just ground up rewrote using Scala Meta, and we're adhering to a strict philosophy of ASTs for every supported language. So we can see here these in Scala Meta you can actually write abstractions that look like normal Scala code, but using quasi-quotes, they're string interpolated. So if you're familiar with Macro Paradise or anything in Scala, it's very, very similar to that, except you can actually do things like this, where you can say def foo string is like triple question. So I can get that reference, but then I can actually say, I'm going to actually pull out like the function name, right? I'm going to actually pull that out of what I've just created, and now I've got this reflected term name foo. That's just staggeringly powerful. So we use this in a couple of different places to make the code easier to write and easier to read as the CodeGen evolves. This is otherwise it's just managing huge trees of AST, and it's just not pleasant. So there's a lot of that in there, and I can show you more after the talk if you're interested. Any other questions? Yeah.
Just wondering what you use for the REPL-based slides.
Oh yeah, Represent. Represent's awesome. Yeah, Represent is a SBT power that uses power features under the hood to do that, and it runs code on each slide. But I didn't set it up correctly because I mentioned that those slides from about 6 months ago. So your user is supposed to be able to go to a slide, run the code on the slide, and it'll actually show you the results in the thing. So it's just super cool. Yeah. Any other questions?
This is awesome. Like you told me about it last night, and like somebody at my company, like 2 people are trying to build like a hand-rolled, crappy version of this. So I told them about it.
Yeah. Oh, cool. Thank you. All right. Yeah. Okay. Yeah. Thanks.